This tutorial once again introduces programmer-defined functions, but after the fact this time. Instead of creating a function in order to be used, well, imagine you already have a huge code and you're starting to realize it's becoming unmanageable or too big or redundant. So after reviewing how to write a function and how they work, we'll do an application to an existing code, a Gulfstream plane that needs to be optimized. We'll do reusability and shortening the code. Common questions and errors not to do will be last. Remember that there's a lot more advantages compared to the disadvantage of using functions. The one disadvantage is we have more .m files, but the advantages are way more important. Focus, independence, memory efficiency, easier to debug, clarity, reusability, and modularity. How do we create a function? The first reflex is to create a brand new script file. Write the word function at the top, your return variables, equal, come up with the name of your function, and then your parameters. If there are more than one argument or return values, separate them using commas. There's two rules to follow to avoid fundamental errors of making a function work. The first one is that parameters should be used within the function body. Parameters are the inputs to your function. Just like any problem where you have inputs or givens. If you don't use them, why bother having them? And same thing for return variables. They must have values before the function ends. So in other words, the parameters must be used inside your code. It might be in a condition in an if, a while loop. It probably could be inside an equation, but it can also be used as an argument to another function, maybe an fprintf. That's the rule. If we forget to use one, remember MATLAB underlines it in orange. Return variables are no different. If something needs to go back out of this function, it is in a variable. So assign, make sure that the variable is placed on the left side of an equal sign. That way it will have a value. So those are the two rules that you have to follow to avoid fundamentally breaking the flow of information. So we're going to apply all this again to an existing code. An aircraft has a size, a weight, and a shape. And for every aircraft there's usually one velocity and one only, at which the aircraft is steady, using a minimum amount of thrust. Steady means no ups and downs, and minimum amount of thrust implies less fuel. So less fuel means less money. So there is a huge advantage to calculating this, and I've started creating a project to optimize the design of my aircraft. Basic, prompt the user for the weight, the surface area, the drag coefficient. This is a value that tells us how good the shape of a plane is. For example, here are some shapes that have a drag coefficient. A sphere is 0.47. A cube is 1.05. So the lower the number, the better the shape is to having the air flow around it. Once we know that value, we can calculate the minimum thrust and the velocity that goes with it. I could push my project further by plotting curves or optimizing the shape of my airplane, but my code is getting too big. As you can see, the code already exists and it runs fine. I prompt for the weight and I error check when it's outside of my boundaries. I prompt for the surface area and again, same error check outside of boundaries. Final input is the zero drag coefficient value, which again has boundaries. Once all my inputs are in, I can calculate the thrust and the velocity. But let's look at the code. it's already 35 lines, and I'm about to start coding more. So I'm going to start losing track of everything. This part from line 9 to 25 is related to the input, and below it's basically related to the output. There's a lot of coding that's redundant. Look at that while loop. It's identical for all three. Sure, the variable name is different, but we have a lower value, we have an upper value, we have an error message that's very similar in all cases. So what if I could just write this once and then call it 3 times, just like the input command? This is when I realize I can write a function myself to do this part over and over again. So I'm going to copy it. To create a function, always start with a new script file. The word function is first, and I basically want this to be generalized, so I can use it for the weight, the surface area, and the drag coefficient. So instead of a weight, I'm going to simplify it to a value. A value needs to be between 2 parameters. So I am generalizing right here my function. The value needs to be between a and b. Those are my lower limit and upper limit. And within here, I need to change everything, but it varies every time. Now I cannot put placeholders inside an input command, but I can put it inside an fprintf. The lower limit is a, the upper limit is b. I will call my function trap limits. I need inputs. If I want to trap a variable, or I want to trap the user when a variable is not between a and b, I need those 3 parameters. I need the value that I typed. I need my a and b limits. When I save my function, remember that the name of the file needs to be the name of the function. MATLAB already knows that, so it gives me the name of the function. As far as returning value, the purpose of this code is to get a value to be between a and b. So while the value is outside of those boundaries, I'm replacing that value. Every time I loop, this variable is being changed. When I'm done and I finally got my value correct, it needs to go back to the main code. So on the left side, I also have my return value. The value comes in the first time. If it's bad, then MATLAB traps it and replaces it. And when it's done, it exits. If the value already comes in valid, then MATLAB will simply skip the loop, but the variable still goes back out. Never forget the documentation. Show the user how to use it by simply copy-pasting the beginning, and if it's not obvious, tell the user what the parameters are. So a is the lower limit, b is the upper limit. The name and your section possibly comes third. Separate the documentation from your name from the regular code by a simple skipping of a line. Now how do I call this function? Well, my keyword is now made. I can replace things here. Instead of value, I want to trap when this variable is bad, so weight. The lower limit for my weight is 60,000. The upper limit for my weight is 90,000. When it comes back, I want to replace the original weight. This goes out the door. For the surface, Notice I'm always copy pasting. This reminds me of the order of my arguments. It needs to match the order of the parameters. When I want to trap user for surface, this is the variable I want MATLAB to check. My lower limit is 800, my upper limit is 1000. And when it comes back, I want to override the previous surface. This goes out the door. Zero drag coefficient. This one's long to type, so I'll copy, paste it. It needs to be between 0 and 1. 0 and 1. This parameter, the first one, is a variable. The second and the third have all been hard-coded every time I called my function. Now here there's orange. This simply tells me that I've never used this actual value. I misspelled the actual word here. So MATLAB is not sending the right variable to the function. So now it's fixed. So let's test it. Let's see if it works. Let's see if we like it. So far, so good. Oh, why does it say wait? It should have said surface, not wait. Easier to debug. Where do I go to actually fix this part? Well, this is inside my function, so I know to look in here. It says wait no matter what. It's pre-programmed to say WEIGHT. That's not what I want. I want it to vary again. The second placeholder needs to hold a word. So I'll call it word. This word depends on my call, on the main code. So I will pass it as a parameter. So now I have to update a little bit everything. Alright, last but not least, if you pay attention to the top, you'll notice a little star. This means that we have made changes to the function that have not been saved. If I go back in my main code and try to run everything, it will still use the old version. So before you get out of the function, always do Ctrl S to save your work. Now that I've fixed it, I can go back in my main code. There is now a fourth argument needed, which is the string that I want to put inside that sentence. Easier to update. I didn't have to fix every single loop. I added one loop. I fixed that one loop. Run again. That seems to be okay. So everything works now. I have shortened my code. I am now at 29 lines of code. We could still push it further. This is related to the inputs. This is related to the output. Let's compartmentalize. Let's create little modules specific for the input and specific for the output. So imagine I want to put all this inside a function. I'm going to cut it out, get my inputs. So now I need to create a new function where all this will happen. So I'm moving pieces of code away from the main code. I'll call it get inputs. Now when you're working backwards and creating functions after the fact, it's a matter of going in your function and figuring out what parameters change, what values need to come back to the main code. If I look on the right side of the equal signs, what values do I need? Is there any variables that are needed? Here, there is none, everything's hard-coded. Here, weight is known from this side, and the rest is hard-coded. There's actually no inputs needed. As far as returning values, which variables have a value? Well, weight has a value, it's been assigned. Surface and zero drag coefficient. That's actually the inputs that I want to go back to my main code. So as return values, I do have 3. Save. Copy. Alright, so I have a function that requires no inputs. It will work on its own. Notice I do not have parameters. I can run this function and MATLAB will start asking for values, trapping, but it will return to me 3 values that are valid. So I'm going to copy paste this again so I can go back to my main code and replace the lines of code that I took away. Now this is different. There is no reusability aspect here. I'm not going to get inputs 3 times. So I can actually stick with the same variables that I have in my function. I didn't have to generalize anything. But all of a sudden we're down to 20 lines of code. Remember we had 35 when we started. Let's see if it still works. So what MATLAB did is it went to this function, fprintf, did its job. Then went into this function. It did recognize that there's a file that exists, so MATLAB went into the function and did its job. So right now it's asking me for the weight. Now it's inside the trap limits function. Now it's back into the main code. Density level K, calculations have happened, and we have our fprintf. So it still works, but notice our code is getting much shorter. Let's do the same with the calculations. This is all about calculating the velocity, so I'm going to cut it, find velocity, and then I'm creating again a new function. Same pattern, you're moving pieces away from the main code. Somehow, if you need values from the main code, they need to be transferred. So I'll call this calculate velocity. What does the function need to work with? Look on the right side of equal signs. Whatever variables appear, if they don't have a value or if they're from the main code, you need to put them as parameters. First variable is zero drag coefficient. It has not been defined anywhere above, so this is a variable that needs to come from the main code. K already exists here. Look at it as intermediate values that you needed. They're not in the main code though. They're just here for the purpose of this little piece of code. Thrust weight minimum is calculated on 12. Weight, that one we need from the main code. Density level is here. K is already known. Zero drag coefficient is already up here. Weight is already up here. Surface, however, is still missing. Thrust min is on line 13 and velocity min is on line 14. Again, all I'm doing is going on the right side of everything that I wrote here on the equal sign. If the variable is known, that's good. If the variable is from the main code, it needs to be a parameter up here. As far as returning variables, what do we write? We don't have too many choices. They must be assigned a value inside your function. So anything on the left side of an equal sign you can actually return. All these are options. 1, 2, 3, 4, 5 options. These have values. But this function is there just to calculate a velocity. So right now it calculates it and prints it. It doesn't really need to return anything at this point. So we'll leave it alone. Don't forget the documentation and save your function. So this is the opposite of the getInput function. If you remember the getInput, there was absolutely no parameters. The calculateVelocity is the opposite. It needs everything in order to do its job, but it returns nothing. So there is no equal sign or brackets. Now that my two keywords are ready to go, I can find my velocity. Again, here there is no reusability aspect. It's more modularity, easy to debug, focusing on a little piece. The variable names happen to match because that's the way the code was built. My code is now 13 lines of code. Notice how big it is. Yet it does exactly what my 35 lines at the beginning did. It asks for inputs and it calculates the velocity. And it still works. So I have 5 lines of code officially. 2 function calls here, getInput and calculateVelocity, that are programmer-defined functions. These, fprintf, clc, and clear, are built-in functions. So the key points here is the code was getting too big, unmanageable, too long, and if you start building on something that's already big, it's going to become a nightmare very quickly. The first function that we created did have a reusability aspect. The trap user was used 3 times. We called the function 3 times. After that, it was more modularity and shortening the main code.